In this example, our designer has a 24-volt, 30-amp system load and wants to ensure that in the event of a power supply failure, the system will keep on operating even during the replacement of a failed power supply. We have chosen a 3-slot rack-mounted enclosure with plug-in TDK-Lambda power supplies connected in parallel to form a redundant power system. Please note that the power supplies electronically current share the load current for improved reliability. Internally, the units have O-ring diodes. These O-ring diodes have two functions. The first function is to protect the DC output bus from a power supply short circuit or failure. The second function is to avoid a dip in the DC output bus when a new replacement power supply is plugged into the system rack. This type of power system is often referred to as a hot swap, redundant, or fault-tolerant power system. The failed power supply is swapped out while the system is still operating or hot, which means the input and output power remains uninterrupted. Here we're going to demonstrate the operation of this redundant power system. We have a 19-inch rack mount enclosure containing 3 power supplies with an electronic load. As you can see, we have a total of 30 amps of current flowing into the electronic load at 24 volts. Because they have a current share feature, these power supplies are each providing 10 amps to the load for a total of 30 amps. If a malfunction occurs, the failed power supply will send a signal and its front panel DC OK green light will change to the DC fail red light to indicate it has failed. The O-ring diode of the failed supply will isolate it from the 24-volt output bus, and the other 2 power supplies will quickly ramp up from 10 amps to 15 amps each in order to maintain a total of 30 amps to the DC bus load. You'll notice the total current has not changed, so that we're still supplying the same amount of current, 30 amps total, with just the 2 remaining power supplies. The failed power supply would be unplugged from the system rack and a new replacement inserted in its place. The new power supply will automatically turn on, and the system load will again be shared equally between the 3 units at 10 amps each, for a total of 30 amps. Not once was the system's DC output bus voltage affected. In this example, we showed 3 parallel supplies with each providing 10 amps at 24 volts or 240 watts each to the load, for a total of 720 watts. In reality, the units shown here are rated up to 960 watts at 24 volts each. So a redundant power system using 3 of these supplies could support up to a 1920 watt system load. And under normal conditions, each power supply would provide 1/3 of the load, or 641 watts each. In the event one supply failed, the remaining 2 supplies would then ramp up to supply 960 watts each, thereby continuing to support the 1920 watt total system load. The latest redundant power supplies and rack mount enclosures from TDK-Lambda is the HFE 1600 series, which feature I2C and PM bus serial communications that facilitates remote control and status reporting from remote stations. With the PM bus interface, the power system can be remotely programmed as well as transmit functional and alarm information. When paralleled, the HFE 1600 series can provide a combined output power of up to 7,600 watts from its 5-slot system rack enclosure, and up to 2 system racks can be connected in parallel to provide up to 15,200 watts of total power.